Hello, this is a short video presentation on our last two methods of factoring. The first one is factoring by grouping. We will factor by grouping normally when we do not have a trinomial or a binomial. Here you see we have 4 terms. We can do it with 4 terms or 5 terms or even 6 terms. We'll primarily work with, possibly only work with 4 terms. What we're going to do in factoring by grouping is group the first 2 terms together, or could be any 2 terms, and we're going to group the other 2 terms together. And we're going to factor. So I look at the first 2 and I see I have an x squared as a common factor. This is a common factor between these 2. And then I pull that out and I have x plus 2. Plus, let's highlight that now. All right, the yellow part is here. We factored that. And now we factor out our common factor of 5. And we have x plus 2. All right, and I'll highlight this green again. This is the green part. When we factor by grouping, we should have, always should have, a common factor after the first step. Notice here, it's not too dark, I hope. I have x plus 2. That will not work. Or we'll go with something else. I have x plus 2, and I have x plus 2. That is a common factor. I factor that out, x plus 2, and I'm left with, over here, an x squared, over here, a 5. I have x squared plus 5. And I'm done. That's all there is to it. We factor, and then we factor again. We group them together, hence the word grouping. So we group, factor, and then we factor again. All right, now let's look at this next one. Whenever we factor, we need to look for common factors. So I have a 3, a 9, a 12, a 36. I know that 3 is a common factor. I have x to the 4th, x cubed, x squared, x. Each term has an x, so 3x is my common factor. So the first step should always be look for common factors. Now I have x cubed plus 3x squared minus 4x minus 12. And now I'm going to repeat the process. Each step along the way I write the 3x. And I factor by grouping. I group the first 2 together, and I group the second 2 together. So when I group the first 2, my common factor is x squared times x plus 3. I group the second 2 together, 4 and 12. Common factor is 4. I have an x plus 3. Now be careful, this is a plus because a negative times a positive is negative. And we notice, once again, that the x plus 3's are common. So then I write 3x, my x plus 3. And when I pull out the x plus 3, I'm left with an x squared and a minus 4. So I have x squared minus 4. Now when we factor until we are done. So I notice with my x squared minus 4 that I can factor that, x plus 3, x and x, minus 2 and plus 2. And now I'm done. This is my final answer. We want to factor completely. But again, we took out the common factor, we grouped, and factored, factored again, and we factored one last time. All right, that's factoring by grouping. The very last thing we're going to look at is quadratic form. And this is very, very simple. I notice that I have a 4th degree, 2nd degree, and a 0 degree term. As long as this is even, the leading one is even, and the second term is half of the first. 4 divided by 2 is 2, it's half of that. I can factor this just like we've always factored. X squared, instead of x and x, it's x squared and x squared, plus 5 plus 3, 5x squared, 3x squared is 8x squared. We're done. That's it. Nothing else. All right? But it's because this was an even number and this was half of that even number. All right, let's look at the next one. First of all, I see that I have a common factor of 2x. I pull out my common factor, like always, and now I have x to the 4th even minus x squared, 2 is half of 4, minus 12. So then I factor. X to the 4th, x squared, minus 4, and plus 3. I check it. Minus 4 plus 3 is minus 1. I'm good to go. But I notice here I have an x squared minus 4, a difference of perfect squares. Well, once again, that's factorable. 2x, x plus 2, x minus 2, and we have x squared plus 3. Always look to see if it's completely factored. Now, when we do this, the 3 things in parentheses, the 3 factors that are in parentheses, the order does not matter. The 2 needs to be first, followed by the x, and then the order of the other 3 does not matter. All right, one last example. X to the 6, 15x cubed plus 56. There is no common factor. X to the 6th even, half of 6 is 3. It's in quadratic form. We hopefully can factor it. To get x to the 6th, it's x cubed, minus 7, minus 8, and this gives us negative 7x cubed, negative 8x cubed is negative 15x cubed, and it works. When I look at my x cubed minus 8 here, though, I have a cube, and I have another cube. 7 isn't a cube, but 8 is a perfect cube. So just like we did last week, x cubed minus 7, and now we do x minus 2, X cubed minus 8 is x cubed minus 2 cubed. So we have x minus 2, x squared plus 2x plus 4. This is factoring just like we did the last couple of days. All right, and now we look at it. Nothing else is factorable. When we factor a difference in sum of cubes, this part will never be factorable, and so we're done. All right, I hope this makes sense. Both of these techniques, using the quadratic form and factoring by grouping, are things that you are expected to know next year. So please learn them for the final and your test, but keep them in your mind for next year. All right, have a great rest of your day, and I'll talk to you tomorrow.